not work. Okay. Okay, so good morning, everyone. I'm Xierong from Xi'an Jiaotong-Liverpool University and the University of the Liverpool. So I'm so happy to have a chance to share our research today. And this is my second time to come to Cambridge, but I'm a little nervous, but it's okay. And I need to thanks for my supervisors, Dr. Fan and Dr. Mahabir, although they can't here. And in this presentation, the main focus of to how facade retrofit strategy for China aging residential communities. So let's begin. In this pre, divided into three parts. First, I will introduce the background and the research gap. Second, the methodology and the case study. Third, I will show results and conclusion. Part one, I will explain why this research is needed. Building and construction plays a significant role in Chinese decarbonization, and which account of 51% of the total emission. And according to our review, recently the building stock gets more and more attention. In 2025, China published the urban renewal policies, and in the statistics books, we can say the huge data sets about the old building before the 2000s, which affects tens of millions of people. And in this presentation, we focus on the facade retrofit because external walls dominate heat transfer, and this can improving the outwards performance can reduce the operational energy defined. And the specific we focus on the two systems, IDP and BIPV. I'm not sure in Europe, although I sometimes were in the University of Liverpool, but in China, these two systems are very popular rather than the traditional method like brick or paint outwards. So IDP is mean insulation, decorative panels, and BIPV is mean building integrated photovoltaics. Did someone know these two systems? Okay. So there have some different advantages in the practice engineering. But I have a question: how to balance carbon reduction and economic performance? So existing studies often focus on the insulation driving energy savings or PV system sustainability. However, fewer studies quantify the full trade-off between carbon and cost when IDP and BIPV combined at renewal facade coverage percent. In my experience in the work in the practice areas, we often install the BIPV in the sun facade because this can receive more sun solar. But how about the remaining areas, and how about to balance the BIPV and IDP? So here are three issues. Maybe you can say, and to solve these issues, so we developed a framework to calculate the life cycle carbon cost and life cycle carbon cost emissions and Pareto analyzing. So please see this this method framework. In this framework, we have the five steps. First, according to the CAD drawings information and standard information, using BIM software can output the facade areas and quantities data. Second, we set the different scenarios from 0 to 100% of the IDP and BIPV, and we create 11 scenarios. Third, using the dynamic simulation like design build software, we can get the HVAC and the PV datasets. Fourth, calculation. According to the Xi'an 15978 and ISO 1568625. The second one, ISO 156. The second one is focused on the building areas. So this is very suitable to calculate the life cycle carbon emissions and the life cycle cost. Finally, we can output the Pareto. We can find the Pareto need points. And in the right side, we have the three sections. It's more details. So please see this by yourself. And in this case study, this study is from China. So that is one case. This case building is a six-story brick concrete resident built in 1992 in Hebei. And this is the north areas in China. In the tables, we give the two systems more key information. We set 7 parameters. We can say materials and U values and cost, design service years, and maintenance and the embodied carbon. In our manuscripts, we have the more details about, say, how to design this scenarios, but in this presentation, I'd like to show this result directly. So we can see these results. S50 is a great result, and this is a key need points. So under the baseline assumptions, no carbon outcomes occurs within an intermediate range of 50 to 60% BIPV coverage. And the LCC is mind mass at 30% BIPV coverage. And the Pareto need point is local. It's not specific. It's neared with 50% BIPV coverage. And I want to say, although this framework can calculate the Hebei's building, but in these studies we just have one case study. So in the future areas we need to verify in the different situations, like brick framework or steam frameworks. Here is some reference. So thanks for your listening.
Thank you, Xierong, for the excellent presentation. Do we have any questions from the floor?